Hello students, so welcome to one more video. Now in this video we are going to discuss two more important topics from the chapter of friction from class 11. Now those who have not seen my previous video, please go and check my previous video in which I have discussed how to find out the acceleration of a block down a rough inclined plane. Okay, that means an inclined plane which has friction on it. Okay, in that video I have also explained what is actually angle of repose. To understand friction or to understand the motion of a body down an inclined plane, you need to understand the angle of repose very properly. Okay. So let us start this video. Over here we are going to do two very important topics. Okay, two very important topics which is related with the motion of a block down an inclined plane. Fine. So this is actually the first one is the external force. External force required to initiate the motion of a block down an inclined plane. So external force required to initiate the motion of a block down an inclined plane. Now what is the meaning of this one? Let us see. Suppose we have an inclined plane over here. This is the inclined plane. Okay. This is the inclined plane. This is the angle of inclination of the inclined plane. Okay. This is the angle of inclination of the inclined plane. This is the inclined plane. Okay. Now I told you in my previous video, if the angle of inclination, suppose the angle of inclination is theta, okay, suppose the angle of inclination is theta. Now if the angle of inclination is less than the angle of repose, okay, if the angle of inclination is less than the angle of repose, what was angle of repose? Angle of repose is the angle of inclination at which the block just starts to slide down with an acceleration. That is known as the angle of repose of an inclined plane. Now, if the angle of repose, if this particular angle of inclination is less, okay, is less than the angle of repose, in that case, if I place a block over here, in that case the block is not going to slide down, okay, because the block will start to slide down at the angle of repose. So if this particular angle is less than the angle of repose, in that case the block is not going to slide down. The block is going to remain in its position because friction is going to hold the body. Okay, friction is going to hold the block. Now let us see what are the forces which are acting on the body. So as usual, this is our mg. This is theta, so mg cos theta. This is our component mg sin theta. And this is r. Okay. And on this side, friction is acting static friction because it is holding the block. Okay. In this side, the static friction is acting, which is holding the block in its place. So the block is not yet it has not yet started to slide down. Okay. Now over here we are going to find out. See, the block is on the inclined plane, but suppose if I want to bring the block down, friction is going to stop. Friction is going to stop the block from sliding down in this particular scene. Okay, but still, if I want to bring the block down, with an acceleration, then what I have to do? Yes, I have to apply an external force. Okay, if I want to bring the block down, I have to apply an external force because in this scenario, the block is not going to come down because frictional force is going to stop the block. Fine. So still, if I want to bring the block down, I have to apply an external force on the block. Okay. Suppose this is the external force I am applying. This is the external force which I am applying. Okay, which is suppose F. F is the external force. F is the external force which I am applying on the block, right? Which is acting at an angle, suppose alpha. This particular angle is alpha. Okay. So I am actually pulling the block with an angle. Now if you ask that, sir, why are you pulling the block with an angle? You can pull the block in this direction also. Yes, obviously I can pull the block along this direction also. In that case, alpha is going to be 0. Okay. If I am pulling the block in this direction, then alpha in that case is going to be 0. But over here I am considering that I am pulling the block with a particular force which is acting at an angle alpha with the plane of the inclined. Okay. So over here you see there are two angles. So theta is equals to angle of inclination. Theta is equals to angle of inclination, and alpha is equals to angle of, or you can say angle between the force F and the surface. Okay, alpha equals to angle between the force and the surface. Okay. Now, this particular force I can divide again into two components. So this will be my one component. In this direction, this is going to be one component, and this is going to be one component. Okay. So these are the two components. So these are the two components. Fine. So if this is alpha, this component is going to be F cos alpha. If this, and this one is going to be F sin alpha. I hope you are understanding the diagram. Here I am showing once again, this was the block, this was the block, this is mg, this one is mg, this is mg cos theta, this one was theta. Okay, so this is mg sin theta, this is reaction force R. Okay, and in this direction I am applying the force. This is the force which is acting at an angle alpha. Okay, so this particular angle is alpha. This is alpha. Now this force I am dividing into two components. So one component will be acting in the direction in which mg is acting, mg sin theta is acting. This component will be acting in the direction in which mg sin theta is acting, and one component will be acting in the direction in which R is acting. So this component is going to be F cos alpha. This component is going to be F sin alpha. Fine. So mg also I have divided into two components. F also I have divided into two components. So suppose F is the force required to initiate the motion. Okay. Now remember, students, over here, the block has not yet started to come down with an acceleration. I am not considering that the block is coming down with an acceleration. I am not considering that situation. That also you can find out, very easy to find out. So that situation I have not yet taken. I have just taken that the block was in equilibrium, forces were balanced, and I have applied an external force. But I am not considering the acceleration here. That means I am not considering the downward motion. Over here I am just trying to find out how much force do you need, how much minimum force do you need to bring the block down. That means to start the motion of the block. Okay, so please be careful over here. I have not taken acceleration. I have not taken the case where I have applied the force and the block is coming down with an acceleration. I have not taken that case. Okay, the block has not yet started falling. The block is still over here. I have applied the force. But over here I am just going to find out how much force is required for the block to come down, how much external force is required. I am not considering the acceleration of the block in this particular video. Fine. Okay. Let us see what are the forces that are acting on the body. So these are the forces which are acting on the body. mg cos theta, mg sin theta, F cos alpha, F sin alpha. Okay. So at equilibrium, what is going to happen? At equilibrium, what is going to happen? Now see, as I told you earlier, before applying the force, friction was stopping the body. Okay, friction was stopping the body. Now this much force I have applied so that the block will now start to come down. Okay, the block has not yet started to come down, but after this the block will start to come down. So at equilibrium, first see the vertical direction. Vertical direction. Okay. So in the vertical direction, you see on this side two forces are acting, F sin alpha and R, and over here mg cos theta is acting. So we can write F sin alpha plus R is equals to mg cos theta. Okay, no problem. From here we can find out R. So R will be equals to mg cos theta minus F sin alpha. So this is your equation 1. Now see along the plane. Okay. So in this direction two forces are acting, that is F cos alpha and mg sin theta. So F cos alpha plus mg sin theta is equals to the frictional force Fs, because these two forces is equal to the frictional force. These two forces is equal to the frictional force. That is the minimum force which I require to bring the block down. Okay, this is the minimum force which I require to bring the block down. Remember, as I said earlier also repeatedly, the block has not yet started to come down. I am just calculating the minimum force which is required for the block to come down. Okay, so this is frictional force. Okay, suppose this is equation 2. Now see, we know frictional force is equals to mu s into R. That is the frictional force. But this is the maximum value of friction. Okay, this is the maximum value of friction. Why? Now I am considering the maximum value of friction. You have to understand the concept. You see, after applying this particular force, after this particular moment which I have considered, after this particular moment, the block will start to come down. Okay, the block will start to come down. That means over here, since I told earlier also, friction is a self-adjusting force, and there is a particular maximum value of friction which it can apply. Fine. So friction is a self-adjusting force. So over here, the friction that is acting now, that particular friction is the maximum value of friction, because after this particular moment, the block will start to come down. Okay, so this particular friction which is acting now, this is the maximum value of friction. So if I use equation 1 over here, I can write F is equals to mu s into mg cos theta minus F sin alpha. Okay, if I use equation 2 over here, in this particular case, I can write F cos alpha plus mg sin theta equals to mu s mg cos theta minus F sin alpha. Okay, so now the equations are arranged. This one you have to solve and find out the value of F. Okay, we have to find out the value of F, the external force. Okay, so F cos alpha plus mg sin theta will be equals to mu s mg cos theta minus mu s F sin alpha. Okay, so this one we can bring to this side. So F cos alpha plus mu s F sin alpha is equals to mu s mg cos theta minus mg sin theta. From here we can take F common. So cos alpha plus F sin alpha, plus mu s sin alpha will be equals to, from here we can take mg common, mu s cos theta minus sin theta. So F is going to be mg mu s cos theta minus sin theta divided by cos alpha plus mu s sin alpha. So this is the value of the external force which is required to bring the block down. Okay, so mg mu s cos theta minus mg sin theta divided by cos alpha plus mu s sin alpha. Okay, so see, this is not the ultimate equation. This one can also be simplified. Okay, this one I am trying to simplify this one. Fine. Okay, now see, mu s I can write is equals to tan theta s. Now what is this theta s? What is this theta s? So this theta s is basically equals to the angle of friction. Theta is basically equal to the angle of friction. Now what is angle of friction? Those who do not know what is angle of friction, I will write it down. So mu s is equals to tan theta s. Theta s equals to angle of friction. Now those who do not know what is angle of friction, okay, angle of friction is basically, suppose if I place a block over here, this is the external force which I am applying, okay, this is the weight of the block, this is the reaction force, and in this direction frictional force is acting. Okay, in this direction frictional force is acting. Now if I draw a resultant of the reaction force and the frictional force, this is the resultant. Okay, this is the resultant. So if I draw a resultant between the reaction force and the frictional force, then the angle between the reaction force and the resultant, that is known as the angle of friction, theta s or theta n. Okay, so this is the external force, this is the frictional force, okay, this is the reaction, this is mg, and if I draw this is the resultant between the reaction force and the frictional force, between the reaction force and the frictional force, then this particular angle, the angle which is between the reaction force and the resultant of the reaction force and the frictional force, that angle is known as the angle of friction. Now over here I have not marked the angle of friction because simply it will make the diagram complicated. Okay, so over here I have not marked the angle of friction. Angle of friction will be somewhere over here in this direction. This is the angle of friction. Okay, I have not marked in this direction. So theta is equals to angle of friction. Now we know that mu s equals to tan theta s. Okay, tan of angle of friction is always equal to the coefficient of friction. Okay, so this one, those who do not know, please see, always tan theta is always equals to mu s. So there is a particular relation between these two. So over here mu s I can substitute with this tan theta s. So I will get f is going to be mg, so tan theta s into cos theta minus sin theta divided by cos alpha plus mu s sin alpha. Okay. So mg, tan theta s I can write as sin theta s by cos theta s into cos theta minus sin theta divided by cos alpha plus. Okay, so mu s again I can write with tan theta s. Here also I can write over tan theta s. So sin theta s by cos theta s into sin alpha. Fine. So that is equals to mg. Okay. Now if you do the LCM over here, you see in the LCM, in the denominator over here one cos theta s will be there, over here also one cos theta s will be there, that too will be cancelled. So I am left with sin theta s cos theta minus cos theta s sin theta. over here cos theta is cos alpha plus sin theta is sin alpha. Okay, this is the expression that I am getting. Now see, in the numerator I have sin A cos B minus cos A sin B. Okay, sin A, sin theta is cos theta minus cos theta is sin theta. So this is of the form sin A cos B minus cos A sin B. Okay, sin A cos B minus cos A sin B. So the formula of sin A cos B minus cos A sin B is sin A minus B. Okay, sin A cos B minus cos A sin B is sin A minus B. Right? In the denominator you see I have cos theta is cos alpha plus sin theta is sin alpha. So this is of the form cos A cos B plus sin A sin B. Cos A cos B plus sin A sin B. So cos A cos B plus sin A sin B, this is actually cos A minus B. Cos A minus B. Okay. So this is the ultimate equation for the external force required. External force required. Okay, to initiate the motion of the block. Again I am repeating, this is the external force which is required to initiate the motion of the block. I have not yet considered the acceleration. Okay, I have not yet considered the acceleration. This is the force which is required to initiate the motion of the block. Now see, in which case this force is going to be minimum. In which case this force is going to be minimum. You see, over here we have mg which I cannot change. I am applying force F. I am applying force F. The only thing which is under my control is alpha, the angle with which I am applying the force. You see, the only thing which is under my control is alpha, because suppose I am applying a force which is of a constant magnitude. So F is only applying. Suppose I am applying 50 Newton force, but in which case the force that I am acting, okay, that I am applying on the body, that force is going to be minimum. Okay, so the thing which is under my control is alpha, the angle at which I am applying the force. Now see, alpha is over here. Now force will be minimum if this particular value, if the denominator is maximum. Okay, now let's find out over here. I hope you have written down everything over here. Okay, so I am rubbing. So see, force will be minimum. Force will be minimum if cos theta s minus alpha is maximum. Okay. So if cos theta s minus alpha is maximum. Now what is the maximum value of cos theta? The maximum value of cos theta is 1. Okay. The maximum value of cos theta is 1. So that is equals to cos 0 degree. Right? So therefore I can write theta s minus alpha equals to 0. So alpha will be equals to theta s. Okay. So this is the condition for minimum force. That means if I apply the force at an angle, okay, if I apply the force at an angle which is equal to the angle of friction, if I apply the force at an angle which is equal to the angle of friction, in that case I will require the minimum amount of force. Okay, and in that case what will be the minimum force? Here I am writing. So what is going to be the minimum force? So if this denominator is going to be 1, then the minimum force is going to be mg sin theta s minus theta. Okay. This will be the minimum force. So this is how we can calculate. How much will be the force which is required to bring a body down an inclined plane. Fine. So I am rubbing. Now see, next we are going to find out something similar. That is, how much external force is required if I want to take the body up an inclined plane. Okay, the previous one was down an inclined plane. Now suppose I want to take the body up and inclined. I want to take the body up and inclined. So external force required to initiate the motion of a block up and inclined. Okay. So let's draw the diagram first. So this is our inclined plane. This is our inclined plane. ABC. This particular angle is theta. Again, as I say, theta is less than theta r. Theta is less than the angle of repose. So this was the body over here. This is the body. This is the body which I have placed over here. So let's see what are the forces that are acting. This is mg. This will be theta. This is mg cos theta. This is mg sin theta. This is r. This is r. Right? Now, over here you see, over here the block is simply kept in this way. The block is simply kept in this way. So, the block is not moving. But, what will happen if I want to pull the block up? See, I want to now pull the block up. So, if I want to pull the block up, I have to apply a force in this direction. Okay? If I want to pull the block up, I have to apply a force in this direction. Fine. So, suppose I am applying the force in this particular direction, that is F. This is the force that I am applying. This particular angle is beta, suppose. Since previously in the last one I have considered alpha, suppose this one is beta. So this one also I can divide into two rectangular components. One component will be in this direction, another component will be in this direction. Right? So this will be F cos beta, this will be F sin beta. Fine. Now see, as long as the block was just simply placed, the block had a tendency to move in this direction, but friction was acting in this direction. That's why the block was not moving, because friction always wants to keep the two things together, the two surfaces together. But once I am applying the force in this direction, then the block has a tendency to move up. Okay, the block has a tendency to move up. So now friction is going to act in this particular direction. Okay, because friction always wants to keep the two things together. So when the block has a tendency to go down, friction is acting in the upward direction. When the block has a tendency to go up, friction will act in the downward direction. Right? So now friction is going to act in this direction. Fs. I hope you understood the diagram. Okay, this is the diagram. Now let us solve. Now theta equals to the angle of inclination. Okay, and theta r, theta is less than theta r. Okay, that's why the block is not falling down. Okay. So at equilibrium, you see, at equilibrium, what is going to happen? So at equilibrium. Again, students, over here, let me tell you, over here, I am just going to find out the force which is required to initiate the motion, which is required to pull the block up the inclined plane. I am not finding out the acceleration. I have not considered the case where the block is accelerating in the upward direction. Okay, that case I have not considered. Just the force I am going to calculate, and I am going to show you how to find out the force. Okay. So first of all, you see, along the plane. Okay, so let us first find in the vertical direction. Vertical direction. Okay. So in the vertical direction, F sin beta is acting in this direction, R is acting in this direction, and mg cos theta is acting in this direction. So F sin beta plus R is equals to mg cos theta. From here, let us find out R. R will be mg cos theta minus F sin beta. Suppose this is equation number 1. Along the plane. So see, along the plane, we have mg sin theta on this side, friction on this side, and on the opposite side f cos beta is acting. So I can write mg sin theta plus friction is equals to f cos beta. Okay, is equals to f cos beta. From here, fs is going to be f cos beta minus mg sin theta. This is equation 2, right? Okay. Now see, we know, as I said earlier also, in this case the maximum friction is acting. Okay, in this case the maximum friction is acting because friction is a self-adjusting force. It can increase and reach to a maximum value, after which it cannot increase anymore. In this case the maximum friction is acting. Okay. So Fs is going to be mu s into, over here I am using suppose equation 1, put the value of r over here. So mg cos theta minus f sin beta. Okay. Again we can use equation 2 also, put the value of fs over here. So f cos beta minus mg sin theta is equals to mu s mg cos theta minus f sin beta. So the equations are now arranged. So now I can just easily solve and find out the value of f. Okay. So f cos beta minus mg sin theta is equals to mu s mg cos theta minus mu s f sin beta. Okay. So bring all the forces to one side, the external forces. So f cos beta plus mu s f sin beta is equals to mu s mg cos theta plus mg sin theta. Now from here I can take f common. So cos beta plus mu s sin beta. From here I can take mg common, mu s cos theta plus sin theta. Fine. Okay. So f is going to be mg mu s cos theta plus sin theta divided by cos beta plus mu s sin beta. So this is going to be the value of the external force. Okay, so this is going to be the value of the external force. So mg into mu s cos theta plus sin theta divided by cos beta plus mu s sin theta. Right? Now this one again can be simplified. I can simplify this one. How to simplify, you see? So we know mu s is equals to tan theta s. Okay, previously also I said mu s is equals to tan theta s. What is tan theta s? Tan theta s basically is the angle of friction. This is the angle of friction. Tan theta is the angle of friction. Okay, this is tan theta is the angle of friction. Okay, so this one I can put over here. So f will be equals to mg mu s. So mu s is equals to tan theta s cos theta plus sin theta divided by cos beta plus mu s is tan theta s sin beta. Okay. So f will be equals to mg tan theta s I can write by sin theta s divided by cos theta s. So sin theta s by cos theta s into cos theta plus sin theta divided by cos beta plus sin theta s by cos theta s into sin beta. Okay. Now if I do the LCM, over here in the denominator I will get one cos theta s, and over here also in the denominator I will get one cos theta s. So that is going to be cancelled. That is going to be cancelled. Okay. So f is going to be mg sin theta s cos theta plus, okay, cos theta is sin theta. Over here cos theta is cos beta plus sin theta is sin beta. The denominator cos theta is going to be cancelled. Now see, in the numerator I have mg sin theta is cos theta plus cos theta is sin theta. That means sin a cos b plus cos a sin b. Sin a cos b plus cos a sin b, that is actually sin a plus b. The formula is sin a plus b. In the denominator you see, in the denominator I have cos a cos b plus sin a sin b. Cos a cos b plus sin a sin b. So that is cos a minus b. So cos a minus b. So this will be the expression for the external force required. External force required. So this is the expression for the external force which is required. Fine. Now, how to find out which is the minimum force that I will require? So as I said earlier, so F will be minimum if cos theta is minus beta will be maximum. Okay. So condition for minimum force. Here I am doing. So I have written everything. So condition for minimum force. Condition for minimum force. Condition for minimum force. So force will be minimum if cos theta is minus beta is maximum. And we know the maximum value of cos theta is 1, which is equals to cos 0 degree. So therefore theta is minus beta is going to be 0, beta is going to be theta s. That means if I apply the force at an angle, which is equal to the angle of friction, as I said earlier also, theta s is the angle of friction. In this diagram I have not marked theta s. Theta s will be somewhere in this particular direction. Okay, this is theta s. So if beta is equal to the angle of friction, then in that case the force required is going to be minimum. Okay, I am going to require the least amount of force. And what will be that minimum force? This denominator is going to be 1, so I am going to be left with mg sin theta s plus theta. This is going to be the minimum force. Okay. So this is how you can calculate the external force required if you want to pull a block down an inclined plane and or if you want to pull a block up an inclined plane. Right? I hope you understood everything in this video. That was all in this video. If you like the video, please like and subscribe. Thank you.